Hello, Coach Travis here with another calculus problem. So, all right, so what we've got here today is we got a derivative problem. So we have this complicated rational function here, and we're being asked to use the limit definition of the derivative in order to find the derivative function for this function. All right, so, and now I want to preface this by saying that again, like we saw with the polynomial problems, what makes these problems hard is the algebra. So the hardest part of this problem is not the calculus, it's the algebra. And this is sort of true for everybody, that often the hardest part of calculus is actually the algebra. So you want to really make sure that you're solid on the algebra. And if you're hoping that the algebra will go away and calculus will get easier, unfortunately, it doesn't really work that way. So the algebra is always going to be with us. And if you want to be successful in calculus, you got to be good at doing the algebra. Okay. So, all right, well, so anyway, so here's the limit definition of the derivative. So the limit definition of the derivative is this expression right here. It's the limit as h goes to 0 of the difference quotient for the function. And as the slide says, the hard part, what we're going to see is the hard part of the problem is going to be having to deal with this numerator here. So this numerator, simplifying that numerator, that is going to be the hardest part of the problem. And in fact, that's the main part of the problem. Once we can simplify that numerator, then the problem will be pretty easy. So, all right, so let's see how that goes. So again, the moral of the story is we have to compute this limit. If you want to compute a derivative, you always start with this limit. All right, so, okay, so if I think about my limit, if I think about the limit definition, we said the hard part of that limit definition was figuring out what that numerator was. So that's what I want to do right here on this slide. I want to figure out, well, what is this expression? And okay, well, the problem tells me that that f of x is equal to this thing. I mean, that's the problem told me that. So I've got that going for me. And I'm going to go ahead and just do a little bit of algebra to simplify this. What I'm going to do is I'm going to say, well, I notice I have a negative. I have a negative that I could factor out of the numerator. And then once I have a negative out in front in the numerator, I can just factor, excuse me, I can just factor that negative sign completely out. So these are the same thing. So, all right, so I think this will make this, I think I'll be less likely to make a mistake if I use this form of f of x instead of the original form. I mean, again, I could have used the original form, but I think this will be, personally for me, I think this will be a little bit easier. Okay, so, all right, and I guess it probably goes without saying, but I'll say it anyway, that I'm probably going to go through this algebra a little bit fast, but the great thing about the video is you can pause it if you need to think about my steps a little bit more. So, okay, so then, all right, so we know what f of x is. F of x is this, or this is the simplified version of f of x. But we also need to know what is f of x plus h. That with f of x plus h, that was an important part of our numerator. So, all right, well, this is a problem in function notation. It's just, well, if this is f of x, then f of x plus h is just going to be the same as this, only everywhere I see an x, everywhere I see an x, I'm going to replace it by x plus h. So I'm gonna have a negative sign because there's a negative sign there. And then instead of x plus 2, I'm gonna have x plus h plus 2. And instead of 6 times x minus 4, I'm gonna have 6 times x plus h minus 4. So again, wherever you see that x, replace it by x plus h. And so you get that expression, and I'll go ahead and just simplify that as well a little bit. I can distribute, I didn't do much there. I guess all I did is I said, oh yeah, those parentheses aren't doing anything because there's no multiplication. So I just erased those parentheses. But then these parentheses are doing something. They're separating that addition from this multiplication. So if I want to get rid of those parentheses, I have to distribute the multiplication. So I get 6x plus 6h, and then there's the minus 4. So that's that. Okay, so let's see what we got here now. Okay, so to summarize, we now know that f of x is equal to this. And we now know that f of x plus h is equal to this. So now we go back to our definition of the derivative, and our definition of the derivative, there's f of x plus h. So this guy, let's see here. So this guy needs to go right here. And this guy needs to go right here. So I'm going to make those substitutions. All right, so then let's get rid of that. So now, all right, so here's, I've got good news and bad news. So the good news is we've got our derivative here. So this is the limit that we have to compute. We have to compute this limit. And right now we're stuck because whenever you try to compute a limit, the first thing you should try is just try plugging in the limit number. So what we should try doing is plug in h is equal to 0. So I should put a 0 there, and a 0 there, and a 0 there. And you should try that. But unfortunately, it doesn't work in this case. Because if you put a 0 there, and you put a 0 there for h, and you put a 0 there for h, then when you simplify this, you will end up with 0 divided by 0. You'll end up with 0 divided by 0. And 0 divided by 0 is never an answer. So if you get 0 over 0, what that means is that there's simplification that you must be able to do in order to actually get a number for this limit. So, all right, so the moral is that we have to simplify this, that this numerator, I think this numerator can be simplified. So that's what we have to do, and that's going to be a lot of work. But that's what you have to do. So let's roll up our sleeves and do it. Okay, so here we go. So here's the numerator. Here was the original numerator from the previous slide. And I know that if I want to subtract, if I want to find the difference, if I want to add or subtract two fractions, if I want to add or subtract two fractions, then you all know that we need to find a common denominator. So before you can add or subtract fractions, you need a common denominator. Okay, so to get that common denominator, what I'm gonna do is I'm gonna multiply this first here's the first fraction, and here it is again, and I'm gonna multiply it by this, and this is just equal to 1. So this thing in the red box, that's just equal to 1. So that multiplying by that's a legal thing to do. And then here's a fraction, and here's the same fraction, and I'm gonna multiply that fraction, I'm gonna multiply the top and the bottom of that fraction by the thing in the yellow box. And hopefully it's not a mystery where those things came from, because this is the denominator of the second fraction. 6x minus 4 is the denominator of the second fraction. And so I'm multiplying the first fraction by the denominator over the denominator of the second fraction. And likewise, this expression is the denominator of the first fraction. So if you want to get a common denominator, then you should multiply your second fraction by the numerator of the first over the numerator. Would I say numerator? I meant to say denominator. The denominator of the first divided by the denominator of the first. Okay, so I did not do a very good job explaining that, but hopefully you can just see from looking at the values what we're doing here. All right, so we're going to do that multiplication. And so then I guess you get what you get. So when you multiply two fractions, multiplying fractions is easy. You just multiply numerator, numerator, and denominator, denominator. So there's numerator times numerator, there's denominator times denominator. And then, oh, I did do a little bit of simplification here. Here's a minus and another minus. So those minuses can knock each other out and make a plus. So that's one little algebraic step I did there. And then now we have numerator times numerator and denominator times denominator. Okay, and now if you look carefully at these denominators, you see a good thing, that this blue thing is actually the same as this blue thing. I mean, they're written in a different order, but it doesn't matter what order you multiply two things in. So this blue denominator is exactly the same as that blue denominator. So we do have a common denominator now, and that is a good thing. That's what we wanted to have. Okay, but before we add these, I want to expand. So I'm going to have to do like a FOIL type business. So I'm going to have to do x times 6x, and then x times -4. And then I'm going to have to do h times 6x, and also h, whoops, and also h times 4. And I'm also going to have to do 2 times 6 and 2 times 4. So I'm doing like if I want to expand these, I have to do like a super FOIL, an extra FOIL, a FOIL with a couple of extra letters in it. But anyway, here I trust that you can do it. And here's what you get. I mean, maybe I can talk you through it real quick. X times 6x makes 6x squared. X times -4 makes -4x. H times 6x makes 6xh. H times -4 makes -4h. 2 times 6x makes 12x. And 2 times -4 makes -8. So that guy, yeah, maybe I'll highlight it. This guy expands to this guy. And now we have to do the same thing over here. We have to do the same thing over here. So let's see here. So yeah, so x times 6x makes 6x squared. X times 6h makes 6xh. And x times -4 makes -4x. And now I have to do it with 2. 2 times 6x makes 12x. 2 times 6h makes 12h. And 2 times -4 makes -8. So this red expression expands to this red expression. All right. So that's cool. And so we're the hard. What do I say? We're getting close. The hard part is over. Now we just have to clean this up. Because if you look at this now, oh no, I guess I'm going to do one other step. I'm going to distribute the minus sign. I have a minus sign here. This minus sign I can apply to everything in the numerator. So I can say, let's see what we got here. So this 6x squared is going to become a negative 6x squared. This -4x will turn into a positive 4x. Positive 6xh turns into a negative. -4h turns positive. So basically, again, this negative sign is just going to flip the sign of everything in the numerator. And it only affects the numerator, right? Because if you have a fraction, like if you have a fraction a divided by b, if you have a negative on the outside, that is the same as just saying a negative in the numerator. Because think about it, if it was a negative if you put a negative in both places, then the negative would cancel. And that wouldn't, then you just wind up with, the negative would go away. And that's not, you don't want that to happen. So the negative only affects the numerator. Okay, and now we get some cancellations here, because let's see what we got here. Here's a negative 6x squared, and here's a positive 6x squared. So when I have a common denominator now, so I can add these fractions, and you know that when you add fractions, you just add with a common denominator, you just add the numerators. And so this is a negative and this is a positive. So those knock each other out. Here is a positive 4x, and here's a negative 4x. Let's see. Here's a negative 6xh, and here's a positive 6xh. Oh my gosh, is everything going to cancel here? Here is a negative 12x, and here's a positive 12x. And then what else? Then here's a positive 8, and here's a negative 8. So all that colored stuff goes away. But you see that we do have some stuff that's still left. We do have a positive 4h is left, and a positive 12h is left. So, okay, so when you add these fractions, the only thing left in the numerator is going to be a 4h plus a 12h. And so that's going to be 16h, right? When you add those when you add 4h and 12h, then you get 16h. So our numerator is just going to be 16h. And the denominator just stays the way it is, because the denominator, when you add fractions, you know, the common denominator stays the same. Okay. So this is what we've got now. We've got now this, that our goal was to figure out what f of x plus h minus f of x was, or at least our sub-goal. And we've now figured out that it's equal to this. So f of x plus h minus f of x simplifies to this expression right here. Okay, so that's going to be important because we went through a lot of work to figure that out. That was really important. All right, so now this can go into the limit, into the derivative formula. So our derivative formula says that we need to have f of x plus h minus f of x there. Oh, but f of x plus h minus f of x is the same thing as this. So what I'm going to do in the next slide is I'm just going to take this fraction and I'm going to put it right in this spot right there. Okay, so there it is. So there's the definition of the derivative, and now I've replaced the f of x plus h minus f of x with that terrible fraction. But it's better. It's better than it was. Okay, and now I think we can simplify this. And it's not too hard, actually. Because, well, whenever I have a fraction inside of a fraction, well, I like to have a fraction in both places. I like to have if I'm going to have a fraction in the numerator, I want to have a fraction in the denominator too. And so anything you can always write as a fraction over 1. So I'm going to write h as h over 1. And the reason I like to do that is then you know that, oh, okay, now you can invert and multiply. When you divide by a fraction, that's the same as multiplying by the reciprocal. So here's my numerator, and here's the reciprocal of my denominator. So those guys can multiply, and look at this. There's an h in the numerator, and now there's an h in the denominator. So those factors of h knock each other out and make 1. So I can basically pretend they're not there. And so the h's go away, and then the 1 isn't important anymore. And so now I have this limit. And now I think it's safe to set h equal to 0 now. Because if you set h equal to 0, well, I'm definitely not going to get a 0 in the numerator because there's no h. So setting h equal to 0 will not give me 0 over 0. So I think we're in business here. So all right, so I'm going to set that h equal to 0. And there's only one h, it's right there. So again, be careful here. You're not setting x to 0. You know, follow the instructions of the limit. The limit says that it's the h that's going to 0. So the x just stays there. So the x's I leave alone, and that single h turns into a 0. And if you think about what that means this term is just gone. Not sure why I highlighted it. I should cross it out. That term's just completely gone. And so look at what you've got here. You've got 6x minus 4 and another 6x minus 4. And so that makes 6x minus 4 squared. And so that now is our final answer. We actually, let me erase that there so you can see what was actually there. Maybe I'll just put a single line through it. There we go. So you can see what's there, but it's equal to 0. Whew. All right, we did it. That was it. I think I'll stop there.